Hello everyone. In this video, we will look at the chirality solver tool. So as you can see, we have a molecule editor in which you can edit the molecule as you want, and there are certain tool buttons to help you with that. So for instance, if you want to add a single bond, you can just press this button and add as many single bonds as you want. You can even change the bond type to double bond, just like this, or you can even change the atom type. So, like from carbon, I can probably change it to chlorine atom, right? And plus, if you do something wrong, you can always like undo or probably redo these things, right? And similarly for arrays, so you can I erase any part of the molecule as you want. Okay, so what happens after editing when I push this button? So it analyzes this molecule and it says that among all the carbon atoms, it's found C1 to be the chiral center in the molecule. So it has numbered all the molecules for of all the atoms for sake, including the hydrogens. Moreover, it also shows how we arrived at this answer that C1 is the chiral center. So, just to go through the step-by-step solution, it first detects what are the sp3 hybridized carbon atom, because those are the only candidates that can be chiral centers. So it sees that carbon atoms C1, C2, C3, and C6. These are the carbon atoms that are sp3 hybridized, which it needs to explore further. For instance, the C4 and C5, these are not sp3, so this is like sp hybridized and this is sp2 hybridized, so it is not considering those as candidates. Okay, so before going further, it pre-processes graph. So we see that there are like multiple double and triple bonds here. So to get the SIP priorities, we need to convert these double bonds into single bonds and then add certain dummy atoms, uh, which have been shaded in this molecule. So instead of like this triple bond, it has added these four different dummy atoms. Instead of these double bond, it has added this two dummy atom, like one oxygen atom and one carbon atom attached to the respective ones. So after that, it checks for each of these C1, C2, C3, and C6 one by one to see if that particular atom is a chiral center. So for carbon C1, what it does is that investigates its or studies its immediate neighbors. So it sees that there are three carbons attached to this carbon and one hydrogen. And it tries to assign priority to each of these atoms. So their priorities, by the way, are assigned based on the atomic numbers of the atom. Uh, and if let's say the atomic number is same, if let's say there are two isotopes, for instance, hydrogen and deuterium, then it looks at the mass number. So for instance, deuterium would get a higher priority than hydrogen, and carbon would get a higher priority than hydrogen because of the atomic number. It sees that among these four atoms, hydrogen has the lowest priority, so it definitely assigns it the priority 4. For the other three carbons, uh, there is no tie break at this stage. So it moves to distance 2 from C1. So at distance 2, uh, for each of these carbons, it says that there are for C3 there is this C6, H5, and H4. For C4 there is nitrogen atom N1, N2, and N3, and for C2 there's like H2, H3, and C5. So it compares these three lists to get the priorities. So it says that N has the highest priority because nitrogen has a higher atomic number than carbon, so it assigns it priority 1. Since but The other ones like CHH and CHH, they are like again we could not break a tie between these two, so it moves to distance 3 for these. So at distance 3, it sees that for this carbon, the neighbors are 3 hydrogen, and for this carbon, the neighbors are 3 oxygen, right? So now At this stage, it says that oxygen has the highest priority, so it assigns a priority 2, and hydrogen gets a priority 3. So now, since all the neighbors of this carbon C1 have been assigned distinct priority, it says that carbon C1 is a chiral center. Okay. Now let's move to C2. C2, it say again when it compares the immediate neighbors, it sees that there are two hydrogen here, uh, and the two hydrogens. I mean, there cannot be any tie break between these two hydrogens, so which means that C2 cannot be a chiral center, right? What about C3? C3 again, so it has these two hydrogen atoms, and it says that the C3 is also not a chiral center. Similarly for C6, so C6 has in fact three hydrogen atoms, and there cannot be so C6 itself can also not be a chiral center. Okay, so this was a brief overview. Feel free to edit the molecule as you want, play around with it, and hope you find this tool useful. Happy learning. Thank you.